Hello, today we are going to discuss about union of set in max of standard 11 of chapter number 1 set. First of all, discuss the definition of union of set. So now, first of all, consider two sets. Let A and B be any two set the union of A and B is the set of all those elements which are either in A or B or in both A and B. Union of set is denoted by A union B. So we can written here it is denoted by A union B. Now what is the meaning of this definition? That means all the element of set A as well as all the element of B we can include in A union B. So it is called A union B. Symbolically we can written A union B is equal to set of X from X belongs to A or X belongs to B. A union B. So in between we can written this notation is OR. So A union B is equal to set of X from X belongs to A or X belongs to B. Now in Venn diagram how can be represented of A union B? So in Venn diagram we can take two sets A and B. Here we can consider set A and here we can consider another set B. Now here universal set U. So A union B, that means all the element of set A as well as all the element of set B. So A union B, that means cover whole this portion. Now we can take one example. A is equal to set of 1, 2, 3 and 4 element is present, and in set B 2, 3, 6, 7, 8 element is present. Now find out A union B. So A union B is equal to set of, first of all the element of set A as well as all the element of set B. So here we can represent it 1, 2, 3, 4. Now here 2 and 3 repeated here, but we cannot return again. So now after we can return remaining element of set B. So here 1, 2, 3, 4, 6, 7 and 8. So A union B is equal to, we get here answer 1, 2, 3, 4, 6, 7, 8. Now after discuss one more example. Exercise 1.4, question number 1. Find the union of each of the following pairs of sets. First question, suppose here two sets is present, x is equal to set of 1 comma 3 comma 5 and y is equal to set of 1 comma 2 comma 3. Now our question is find out x union y. So first of all we can return element of set x. Here first position is x union y. So first of all we can return x element of set x is equal to 1 comma 3 comma 5 union element of set y 1 comma 2 comma 3. So is equal to now 1 answer is all the element of set x as well as all the element of set y. So our answer is 1 comma 2 comma 3 comma 5. No any element repeated in this set. Next one, second one, a is equal to set of a comma e comma I comma o comma u set over and b is equal to set of a comma b comma c set over. Now again our question is find out a union b. So a union b is equal to set of a e I o u. Again here a is present here, so remaining element b and c. So we can return a union b is equal to set of a e I o u b comma c. Now next question, third question, a is equal to set of x from x is a natural number and multiple of 3 and b is equal to set of x from x is a natural number less than 6. So now here in set of a, first of all here condition is present, a is equal to set of x from x is a natural number and multiple of 3. So we know that a natural number, that means 1 2 3 4 5 6 7 8 is it's all are natural number, but here one more condition is present and multiple of 3. So multiple of 3 that means here we can only consider set of 3 comma 6 comma 9 comma 12 up to infinite. And in case of b, x from x is a natural number less than 6. So natural number less than 6, that means 1 2 3 4 5. So now after find out a union b, so a union b is equal to set of, first of all we can return here 1 2 3 4 and 5. Now after 6 9 12 up to infinite, here we can return up to dot dot dot, here we can return set over, so answer is wrong. So here up to infinite form is present, so that's why here in a union b answer we can return this form. Now after discuss one more example, question number 4. Question number 4. A is equal to set of x from x is a natural number and 1 less than x less than equal to 6, and b is equal to set of x from x is a natural number and 6 less than x less than 10. So now, first of all, here condition is present, x is a natural number, and another condition is present, 1 less than x less than equal to 6. So here we can written set of element of a is equal to 2 comma 3 comma 4 comma 5 comma 6, and b is equal to set of, here 6 strictly less than x less than 10, but that means we can consider the element between 6 and 10. We cannot consider 6, we cannot consider 10. So between element and natural number means between natural number is 7, 8 and 9. Now again our question is find out a union b. So a union b, that means 2 comma 3 comma 4 comma 5 comma 6 comma 7 comma 8 comma 9. Next question, a is equal to set of 1 comma 2 comma 3 and b is equal to null set. Now after find out a union b, so in set of a total 3 element is present, and in set of b null set form is present, empty set is present. So a union b is equal to, here we can written 1 comma 2 comma 3. Now after discuss one more question, if we can consider 4 set, if a is equal to set of 1 comma 2 comma 3 comma 4, b is equal to set of 3 comma 4 comma 5 comma 6, c is equal to set of 5 comma 6 comma 7 comma 8, and d is equal to set of 7 comma 8 comma 9 comma 10. Now find out first question, a union b. So now here find out a union b. So first of all we can return the all the element of set a. So here we can return 1 comma 2 comma 3 comma 4 union set of b, that means 3 comma 4 comma 5 comma 6. So is equal to all the element of set a as well as all the element of set b. So 1 comma 2 comma 3 comma 4 comma 5 comma 6 set over. Now second condition, a union c. A union c, that means all the element of set a, that means 1 comma 2 comma 3 comma 4 union all the element of set c, that means 5 comma 6 comma 7 comma 8. So is equal to a union c, that means 1 comma 2 comma 3 comma 5 4 5 6 7 and 8. Now next one, b union c. B union c, that means all the element of set b as well as all the element of set c. So first of all we can return all the element of set b, that means 3 comma 4 comma 5 comma 6 union set of c, that means 5 comma 6 comma 7 comma 8. so is equal to B union C. That means answer is 3, 4, 5, 6, 7 and 8. Next one, A union B union C. A union B union C, that means first of all return the set of element A. So 1, 2, 3, 4 union set of B, that means 3, 4, 5, 6 union set of C, that means 5, 6, 7, 8. Now union of all these three elements, that means A union B union C. So here we can written 1, 2, 3, 4, 5, 6, 7, 8. Next question, fifth one. A union B union D. So A union B union D, that means first of all return element of set A 1, 2, 3, 4 union element of set B, that means 3, 4, 5, 6 union element of set D, so 7, 8, 9, 10. Now after final answer, so all the element of set A as well as all the element of set B as well as all the element of set D. So here we can written 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. Okay. Now after one more question. Question number 6 related to this topic. A union B union C union D, suppose. So here we can written A, that means 1, 2, 3, 4 union B means 3, 4, 5, 6 union set of C, that means 5, 6, 7, 8 union set of D means 7, 8, 9, 10. So here all the element of set A as well as all the element of set B as well as all the element of set C as well as all the element of set D. So our answer is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now after discuss some properties of union of a set. So properties. So first properties, commutative properties, otherwise we can say that commutative law. So in commutative law, A union B is equal to B union A. Now we can prove one property, means first properties. So we can take one example. Suppose A is equal to set of 1, 2 and 3, means 3 element is present, and in B is equal to set of 3, 4 and 5. Now first of all in LHS side we can written A union B, that means first position of set A, so we can written 1, 2, 3 union second position of set B, so we can written 3, 4, 5. So now A union B, that means answer is 1 comma 2 comma 3 comma 4 comma 5. Now in case of RHS side, B union A. Now in case of B union A, first position is set B, so we can return 3 comma 4 comma 5 union. In case of set A, 1 comma 2 comma 3. So again same answer, 1 comma 2 comma 3 comma 4 comma 5. So in LHS side and RHS side both are equal in this case. So first property, commutative law, means A union B is equal to B union A satisfied. Now second property, similarly we can return second properties, associative law. So A union B union C is equal to A union into bracket B union C. Now same properties we can using by example, and we can prove these same properties. Now third one, identity law. Otherwise identity laws. So A union null set is equal to A. Fourth properties, idempotent law. In idempotence law, A union A is equal to A itself.